In this example, we're going to show how to batter piles and support those piles with spring supports in Adapt Builder 2019. We'll go ahead here and open Builder. We're going to open Builder in RC. This could be done in either RC or PT RC mode, and kind of what we're looking at here is if we have a mat and we might have piles that have some batter to them or angle to them, they're inclined. We want to be able to model those piles, and then we want to be able to place a spring, maybe this is a compression only spring, at the base of those piles. This is done in a specific way in the program, and again this can be done in RC or PT mode. We'll use RC mode and say OK there. We'll go ahead and get rid of that drawing, and the first thing we'll do is just model our this might be a mat foundation, it could be a pile cap, it could be just something supported on piles. So we're going to model that as a mat. It's important to also note we're working in Floor Pro mode because this has to be elevated, so we're using the tools in the program that allow us to model an elevated slab component. And once we model our slab in, like so, we're going to add some piles, and I'll just take these piles. I'm going to do 2 on one side, 2 on the other. So pretty simple model, but it should illustrate how to handle this. For the piles, I'll make these circular. They're going to be, let's say, 18-inch diameter piles, and I'm going to go ahead and place one here, and then we'll do a couple more over there. Okay, and then I'm also going to increase the story height here, something a little more realistic. I'll say that these piles, the height of this pile or this level is, let's say, 20 feet. So I'll apply that, and on the side this is kind of what it looks like. I'll make this slab something a little bit thicker, maybe 24-inch mat. And I could also adjust those so they're offset from the top of the slab, so I could connect the supports, or I could socket these into the mat. If I extend them upward, what I would do in that case is select the pile like so, and at the top here I would do a extension down of the depth of the mat minus the socket. So if this might be, for example, a 4-inch socket, I'll do a 20-inch extension, something like that. So that's the first step. The second step will be to incline the column, or the pile. So I'll take this pile, go to location, and I'm actually going to take the bottom of the pile and I'm going to move it over 5 feet. So this is going to be -60. This could be in the X and Y direction. We'll just go in one direction here. This will be -60, and then on the other side I'm moving the bottom over +60. This is in inches, and +60. So now we have something that looks like this. Okay, so after we extend these out, what I'm going to do is I'm actually going to go back to model, and before I analyze, I'm going to just see where if I create supports, the program is going to add supports at the end of the column, or in this case the pile, the inclined pile, and you can see there's a point support there and there and so on. So what we have to do in order to replace those point supports with a spring is I have to user modify those supports. So I can go into each of these supports and actually just turn off all of my restraints. I deselect everything. That's a user modification. So now there's essentially no support there. I could do that all at once. I can select, modify. Let me see if I can select those first. I'll select the point supports, and then I'll modify the selection. And under point support, I can just go to user define and just set everything off. Now this is basically unsupported. In fact, if I was to analyze the structure, because I made a user modification to the supports, there's actually a setting here under analysis and design options. It says retain the user modification and create everything else as shown below. So this controls that because I retained it and I user modified it, it will retain that setting until I actually delete out these supports. So if I mesh this slab and I analyze, I'm going to get a stability error because it's unsupported. I'll just get massive displacements, and you can actually see the displacement here is huge. So now what I can do is I can add a, um, a spring. So let's go back to model, and I'll go and turn on the visibility of the point supports again. And now what I'm going to do, let me clear out the mesh here. I'm going to erase the mesh, and I'm going to go to model, and I'm going to say spring. And for this spring, I'm going to do a few things. I'm going to first go into the properties, and you could post edit the spring, but I'm going to say it's compression only. I'll set up my stiffness XYZ directions here, and I'll just say that's 100 kips per inch. And then under the location tab, I'm going to offset this downward. So we know that this is 20 feet, so it's 240 inches downward. And I'll just go ahead and select that, or I'll input that, and I'll just place one of the springs. So when I place this spring, I'm actually going to place it just here at this location where we have this point support. So it's 240 inches down, and then wherever I place it, there. So I'll turn on this option there. I'll just add the spring kind of where I have those point supports. We know that the point supports are essentially zeroed out, and now those springs are shown like so. So the location is down 240. This is the coordinates of the springs. Now what's important here is that when we mesh this, that the program meshes to the springs. Okay, so I'm actually going to either reduce the node shift. If I mesh this as is, you'll notice that the elements actually get straddled. This spring is straddled by the shell. So if I execute this, let me turn off the stabilization option, we're going to get a stability problem because we're not meshing to that spring. We have to mesh to the spring. So one thing that we can do here is I'll clear out the mesh. I can then remesh, and I'm going to either reduce the mesh size so that it's smaller than this distance between slab edge. So this might be like a 0.5 inch node shift. Now you can see it's connecting to the spring on those elements there. Or I can just simply turn off node shifting. For some slabs, node shifting might be useful. For this slab, we're going to just turn it off altogether. We still get a pretty good arrangement. And once I've done that, then I can execute. Again, my point supports are zeroed out. The spring is now supporting this, and you can see now we have some axial force in these inclined members. This is the axial force we're showing. We have some displacement here. We can animate that, and then finally, if we look at the spring reactions, let me go back to here. In fact, I'll turn on the column. These are identified as columns, but they're really inclined. So if we go to actions, we can show different actions for the different types of components. Ultimately, we might want to see those spring reactions. So if I go to point support reactions, the point support reactions should all be 0, which they are. Okay, the point spring reactions should be non-zero, and those are all non-zero. These are vertical reactions, horizontal reactions for the springs. And you can see we have a pretty significant horizontal reaction at the point spring. So that is how you would make the modification, in this case, to not only incline the column, or in our example, a pile, and also add a point spring at the base of the pile. Thank you.